Okay, so when we are using Pearson-r, we are actually figuring out correlations, or we are answering the question, is there a significant correlation? This is a measure of association. It is a measure of association. Okay, so here, what we need to do is to do the scatter diagram first. So can you see the whiteboard?
Yes, ma'am.
Given two variables, so the variables must be numerical. It's numerical data. So if you still recall our discussion when I asked you to determine whether the variables are qualitative or quantitative. So using this test, our variables must be quantitative. So it's numerical. And then we have to use a scatter diagram to see if there is a possible relationship or possible correlation between these two variables. And some of the forms that we might encounter are the following. So we have, for example, okay, let us see. So graph that might look like this. So it says scattered. This is our X and this is our Y. Or it might look like this. Or like this. So if we are going to form a line, so we cannot form a line in this figure. So let's say this is our figure 1, figure 2, and figure number 3. So if in the analyzing or in coming up with a scattered diagram, we encounter this figure 1. So this is actually a positive correlation or positive relationship. This is scattered and it seems that there is no line that can be formed here. This is no correlation or no relationship. And this is negative correlation. So the perfect correlation is positive 1 and negative 1. If it is positive 1, it means that there is a direct correlation. So how can let us move you here. Okay, so for example, we need another board. Okay. So for example, if the computed values for our data, so let us use a dummy data. Let's say variable 1 is knowledge. Can we use? And variable 2 is skills. So we want to know if the individual is knowledgeable, it means that he or she is also skillful. So they are given both tests for knowledge. For knowledge, for example, so it's a written test. And for the skills, it is practicum. So it's a practical test. So from 25 items assessment provided, here are the following scores. So 14, for example, and then for skills, respondent number 1 obtained a score of 15. Respondent number 2, knowledge is, let's say, 20, and skill is also 21. 25, perfect for knowledge but not perfect for skills. So this is an example of the data, and we want to know if there is a significant correlation between knowledge and skills. So how to do this? So we are going to use Microsoft Excel in computing. So what we need to do is to open Microsoft Excel. Wait, so you cannot see the Microsoft Excel, right? Can you see it?
No, ma'am.
None. So we have to go again to our main share. Okay, so here is our data set, for example, for skills, and okay, let's rewrite that to knowledge, and the other one is skills. So this is a dummy data, 15, 15, 18, 19, 19, 20. So this is just an example. 19, 17, 16, 15, 20. So let's have 10 data. Okay. So given this data, we will figure out if there is a significant correlation between knowledge and skills. So to do that, we have to access data analysis, and then locate regression. So if you do not have data analysis yet in your Microsoft Excel, you can proceed to File, Options, and then Add-ins, and make sure that we have highlighted here Analysis Toolpack, Excel Add-ins, click Go, and then click OK. So that is in case you cannot find this option under Data. Okay, so what we need to do is, again, let's go back to the procedure, data analysis, and locate regression, and click OK. So our input Y and input X, so assuming that it's a simple linear regression, so which means if you know the example, the knowledge, is it also possible to predict what will be the skills? So let's say that knowledge will play the role of independent variable here, and skill will be the dependent variable. So let us place the skill as our Y, and X will be knowledge. It's independent variable. So since I highlighted the first row, I have to click labels. And then just click OK. So here is the table that we need. So we already have the value of R. This is the value of R. It's 0.04. And then R squared. So R squared is coefficient for the termination. It is just simply multiplying our R by itself. And the result here is 0.002. So as I mentioned in our discussion, I mentioned that the perfect correlation is 1, positive 1 or negative 1. So this value is positive 1, so it means that it is a positive correlation. However, the value is very low, that it is already very close to 0. So as positive 1 and negative 1 is the highest correlation, or actually it is the perfect correlation. We cannot obtain a value of higher than 1. So we cannot say that the R is 1.25 or 1.5 or 2. So the highest is 1. While if it is 0, so let us try to draw this. Let's go back to our... So let's see. If it is 0, there's no correlation. So this is negative 1, this is positive 1, this is the perfect correlation. So if this is positive 0.5 and negative 0.5, the values between 0 to 0.5 can be said that there is a weak correlation, while from 0.5 to 1, there is a strong correlation. So the same thing on this side, if it is 0 to negative 0.5, we can say that there is weak correlation, and it is also strong correlation for negative 0.5 to negative 1. So it is a negative strong correlation or negative weak correlation, positive weak correlation, or positively or positive strong correlation, or strongly positive correlation. So it can also be stated that way. Okay, so let us go back again to our... So this is very low. So it is weak correlation. Actually, it's almost 0. So it's almost no correlation. So what we need here is this value. We just need this 2. And then aside from that, if we are going to move here, we can get the formula, the linear regression equation. So y is equal to 21.44. I just round this value, plus, or rather it is a negative, so it's a minus 0.07x, where x is the knowledge and y is the skills. So what is the meaning of this? So it means that it's a negative. So the influence of our knowledge is negative. So for every increase of 1 unit in knowledge, it means that there is a decrease in the skills. But we have also to take a look at the value of this one, our p-value. So this is what we call as a p-value. It is 0.9. This must be less than 0.05 to say that there is a significant linear correlation. So here, there is no. So we are comparing it with 0.05. It is, if it is less than 0.05, it means that it is significant. So in the case of this, it is not significant. So therefore, our conclusion is that there is no significant correlation between knowledge and skills. Because of course, if we look at this value, this is very low. It is almost no correlation as I have said. So we have here our R squared, the P value to indicate that there is or there is no significant correlation in our equation. So this is all for our lecture for correlation and linear regression. So in next meeting, so what we need to do is, of course, to test if you can also do this, the procedures. Did you follow the procedure? May I know if, did you follow the procedure? Hello? Are you still there?
Hindi masyado, ma'am.
But
Dun
is it
sa
clear
start,
in
ma'am.
your slide? Is it
Yes,
clear
ma'am.
in the... okay. So you can actually go back to this video because it's recorded. So what you need to place later in the paper is the value of R, the value of R squared, and the equation. And then also to give later an interpretation whether there is a strong correlation, there is a weak correlation, and what is the meaning, for example, if there is a positive correlation. The meaning of this, if it is positive, it means that as X increases, Y also increases. So in case that, for instance, in our example, the value is positive and it is strongly correlated, it means that the more knowledgeable the student, the more skillful is also the student. Or if it is negative, so this means that as X increases, Y, as X increases, Y decreases. So it is inverse. It is also called inverse correlation. So you might encounter the word inverse instead of negative correlation. So negative correlation is the same with inverse correlation, while positive correlation is the same as direct correlation. So here, as X increases, Y decreases, or vice versa, which means the more knowledgeable the student, the less skillful he is. So this is for the negative. And for no correlation, it is 0. It means that the increase or the decrease in knowledge has nothing to do or is not associated with his or her skills. Okay, so that's it. So it's already 30307. So it's already time. For other questions, you may just message me or you can post it in the GC. So in case that you cannot follow the procedure.